Go on, take a deep breath. Feels simple, right? But with that one breath, you're tapping into this huge invisible shield that wraps around our entire planet. I mean, it's the reason we have blue skies, crazy storms, and, well, everything in between. It's literally why we're all here. So today, we're going to take a journey right into that shield, our atmosphere. You know, when you see pictures of Earth from space, it's just, wow, this incredible marble of blue, white, and green. But the most important part? It's also the most delicate. Look closely at the edge. See that thin, glowing blue line? That's it. That's our atmosphere. It's the only thing between us and the total emptiness of space. And it's where everything happens. Every cloud, every storm, every single breath. So what is this thing? This protective bubble? How does it cook up all the weather we see every single day? You know, from a nice little breeze to a monster hurricane. Well, that's exactly what we're going to figure out. Okay, but before we go blasting off into the sky, we gotta get our bearings. We need to see where the atmosphere fits into the grand scheme of things. And it all starts right here, on the ground, in what's known as our planet's life zone. And that life zone has a name, the biosphere. And really, it's just this incredibly thin skin on our planet. But think about it. Everything alive is in that layer. From the tiniest little microbe to a giant blue whale, it's all right here. It's the stage for, well, the entire show. But the biosphere isn't just one solid thing. No, it's this super dynamic system where everything is connected. It's actually made up of three crucial parts, and they're all constantly interacting. So you've got the land, which is the lithosphere, you've got the water, the hydrosphere, and of course the part we care about today, the air, the atmosphere. Now, each of these is a huge topic on its own, but right now we're all about that massive ocean of air above us. All right, you ready? Let's imagine we're stepping into an elevator. We're hitting the button for the top floor, way, way up. We're going to ride through all the different layers of our atmosphere, straight to the very edge of space. See, the atmosphere isn't just one big soup of air. It's more like a layer cake, neatly stacked. We're going to start at the bottom and work our way up, through the troposphere, the stratosphere, the mesosphere, and the thermosphere. Ding! First floor, the troposphere. This is our stop. This is where we live. Every cloud you've ever looked at, every flight you've ever taken, it's all happening right here in this layer. So this layer goes up about 10 kilometers, and this is the big one. All of our weather happens here. The name kind of gives it away. Tropos is Greek for change. And believe me, this layer is always changing. It's constantly mixing, churning. That's what gives us everything from a nice breeze to a crazy thunderstorm. And yeah, just like climbing a mountain, the higher you go up in the troposphere, the colder it gets. Okay, going up. Next stop, the stratosphere. It's a lot calmer up here, but this layer has something that is absolutely essential for us to survive. Think of it as Earth's built-in sunscreen. This is where you'll find the famous ozone layer. Its job is to soak up most of the sun's really nasty ultraviolet radiation. But here's where things get weird. Remember how it got colder as we went up before? Well, here it actually gets warmer the higher you go. So what's up with that? It's that ozone layer. It's grabbing all that energy from the sun, and that process actually heats this layer up. All right, back in the elevator, heading up again. Welcome to the mesosphere. I like to think of this as our planet's personal cosmic shooting gallery. This is the middle layer, and it's basically our shield against space junk. Most of the meteors that come flying at Earth, they burn up right here from the friction. And that fiery streak is what we see as a shooting star. It's also really, really cold. We're talking temperatures dropping down to minus 100 degrees Celsius. Brr! Okay, now prepare for some serious temperature whiplash. We just left the coldest layer, and now we're heading to the hottest. Our next stop is the thermosphere, and the temperatures here can hit an unbelievable 2,500 degrees Celsius. I mean, that is hotter than a blast furnace. But, and this is going to sound crazy, despite that insane heat, if you were just floating around up there, you would freeze to death almost instantly. So how on earth does that make any sense? Well, the secret isn't about heat, it's about density, or really the lack of it. The air molecules up here are super energized. They're zipping around like crazy, and technically that makes them hot. But there are so few of them and they're so far apart that they'd almost never actually bump into you to transfer that heat. It's kind of like, how a single tiny spark from a campfire can land on your hand and you barely feel it? But if you stick your hand in a pot of boiling water, which is way cooler than that spark, it's a big problem? It's the same idea. There just aren't enough molecules to make you feel the heat. Okay, so our little trip to the edge of space is over. Let's hop back in that elevator and ride it all the way down. We're going back home to the troposphere. Because now that we've seen where everything is, we need to understand why it all happens. What's the engine that powers all this weather we live with every day? The answer, it turns out, is incredibly simple, incredibly powerful, and it's about 93 million miles away. Yep, the ultimate engine for all of our weather is the sun. Every gust of wind, every single raindrop. At its core, that's just our atmosphere doing its job, moving the sun's energy from one place to another. But here's the key. The Earth doesn't get heated evenly, not at all, because we're a sphere, right? So at the equator, sunlight hits directly. It's like pointing a flashlight straight at a wall, a bright, concentrated spot. But at the poles, that same beam of sunlight comes in at an angle and gets spread out over a huge area. It's way less intense. And this difference, this fundamental imbalance of heat between the hot equator and the cold poles, that is what gets the whole global weather machine started. So we've got our power source, this uneven heating from the sun. The next ingredient in the recipe for weather is the constant back and forth between the land, the air, and the water. It's this beautiful, complicated dance that creates the local weather that you and I actually experience. Let's make this super simple. Think about a classic sea breeze on a hot day at the beach. The sun's beating down, right? The land, the sand, it gets hot fast, much faster than the water. So what does hot air do? It rises. And when it rises, it leaves behind an area of low pressure. Meanwhile, out over the cooler ocean, the air is colder and denser, so it sinks. That creates a pocket of high pressure. And nature absolutely hates an imbalance. So that cool, high-pressure air over the water rushes in to fill the low-pressure spot over the land. And boom, just like that, you get that amazing, refreshing sea breeze. So when you really step back and look at the whole thing, you start to see it. Our atmosphere is just this incredible, complex engine. The power source is a star 93 million miles away, and the gears are this constant, beautiful dance between our planet's air, its water, and its land. And we depend on this layer, this incredibly thin, always moving layer, for absolutely everything. For every breath we take, for every drop of rain. It really is our planet's invisible shield. Which, of course, leaves us with one last really big question to think about. What does the future look like for this fragile system? The one that makes all of this possible?